here we are going to explain a little bit that a small difference that you may notice between the slides that we provide versus the textbooks that we intend to use. It is about relationship between thermal vibration frequency and successful jumping frequency. Successful jump frequency versus vibration frequency. Okay, and from what we discussed before, thermal vibration frequency, or mu, is essentially the frequency of a atom or molecule or ion um, thermally vibrate around its equilibrium location. Typically, it's a very high number. The atoms would always vibrate and attempt to leave its location. But among most of the attempts, it goes back, it's still, and then tries again. But most of the cases, it doesn't move anywhere. That's so-called thermal vibration frequency, the frequency of atoms thermally vibrate or attempt to move around its equilibrium location. Okay? And then in this class about diffusion, we introduced the so-called successful jump frequency. The successful jump frequency, gamma B. To talk about gamma B, let's first take a look at a arbitrary uh, Gibbs free energy plot of Gibbs free energy versus location. Okay, let's assume that our atom is initially at this valley or equilibrium location, and in order for that atom to move to a different location at a certain distance or far away from its original location, and naturally it always have to overcome a so-called migration barrier. Could be essentially what we call the activation energy, delta GM. And the relationship, as we talked about in this class, the successful jumping frequency, gamma B, gamma for successful jump frequency, B for, let's say, impurity atom, is related to the vibration frequency times a exponential factor, a probability that is delta GM, the migration barrier, divided by RT negative. That gives us the probability for a individual jump to be able to overcome this barrier and land in the neighboring site. Okay, of course it has a negative in the exponential term, which means it's always a probability, it's always a positive number, but it's a slow, it's a low probability. Like the extreme case would be okay when t goes to positive infinity and the thing, this exponential term approach zero, and in that case the exponential term approaches zero. This entire exponential term approaches, excuse me, not zero, but 1, and it has the high probability to overcome it. But when the t is low, close to 0, and within this bracket is approach negative infinity, and the total exponential or the probability is essentially 0. That means it cannot overcome this barrier. That's the relationship in this class that we talk about successful jump frequency gamma versus the vibration, thermal vibration frequency mu. On the other hand, if you read the textbook, especially in the biportal on page around 72 to 73, the successful jump frequency was written in a slightly different fashion as what I give here. Gamma B is Z times mu prime times the exponential term or the probability term. And here, according to the textbook, they define mu prime for in one direction. For the along one direction, the atom of interest makes mu prime attempts per second, or the frequency for that atom to move along one direction. along a particular direction or to a particular side. That is mu prime. And then z, in this equation, z is the number of such sides, or all the possible interstitial sides if we are talking about interstitial diffusion in three-dimensional. Of course, naturally, you can see that what we define as mu would roughly be equivalent as the product of the number of sides times the frequency along a particular direction to a particular side. Okay, that's the relationship between our description here versus a textbook description. So in our case, as far as I see, I do not see the benefit of introducing this actual term of z and v prime, and therefore it was not exactly adopted in our textbook, in our slides, and I just use thermal vibration frequency mu, and times the probability due to the thermal barrier. Okay. And this just explains a small difference that you may see between the slides that we use versus the textbooks that we specify. Okay.